Well, welcome to the next lessons, and this is actually being filmed in Thailand. So I'm gonna show you the view around my country so that you can see where I am from actually. So let's get back to our lessons right here. So as you can see right here, right, this is a drawing part where everyone right now should be familiar with the system. So what it is the mass itself, right? It's being attached to the string, which is attached to the wall. And then this is the K, which is constant. And this is the X, delta X is the displacement. And also the object is also being pulled. Actually, it's being attached to the stringless with no tension at all. So this is what you will be thinking of when you're dealing with this problem. You're gonna go ahead and just gonna go ahead and write down what the question you should be thinking of. You know, what would happen if? So if the string is actually cut, what would happen? So there are multiple interpretations based on this system. So when the string is cut, obviously this object right here will actually being dropped due to gravity. So let's go ahead and write down what G is. 9.8 meter per second square. So if you don't see this one, just don't worry about it. So I'm just gonna go ahead and write it down over here for you to figure out what it is. So it would be gravity, which is 9.8 meter per second square, right? So what would happen when the string is cut? This one, will actually drop down. So you're gonna use the kinematic. So let's go ahead and solve this one right now before we forget our lesson from the first semester. So go ahead. I'm just gonna go ahead and keep drawing this part right here. Can you see it? This object right here is being dropped. There's no more tension. So that's the only force that acting upon the object itself. So we're gonna go ahead and look down over here to see how far the object is actually, from the floor. This is delta Y. So I'm just gonna go ahead and say delta Y is 10 meters. So what else do we need to know in order for us to calculate a certain thing? Let's just go ahead and solve for time since we know the height. We know the acceleration for sure, so I'm just gonna go ahead and use this kinematic formula right here. So it will be delta Y is equal to V O Y plus 1/2 G squared. So this is actually the kinematic equation that you guys should be familiar with already since we will test this for the first semester. But everything that you've learned will be carried out throughout the semester all the way until you take the final exam, which is going to be an AP test. That's why I'm keep tied, new concept with the old concept, so that way you won't forget. There's no choice for you to be forgetting. So this is the next lesson. We're going to treat this one in just a minute to see what happened there, okay? So right here, since the object right here, initially there's no movement, so that velocity right here is actually what? A 0. So therefore I can just cancel this term out. So do I know the height? Yes. I'm just gonna keep write down the height first, and I'm gonna keep rearrange the equation to solve for time. So that way right here we have 1/2, right? We still have G T squared. So in order for us to solve for time, I'm just gonna go ahead and rearrange the time on this side right here. So that would be 2 times delta Y and multiply both sides with 2. That's why I have it right here. So this term itself cancel out. And then I'm doing this since that I'm divided by G. And then to get rid of the square, I need to square root that. That's how much time it takes for the object right here to drop all the way to the floor. And then you can just go ahead and your task right now is to go ahead and apply all of the information that you have right here Actually, you have the mass. I'm just gonna go ahead. The mass is 5 kilograms. So you're gonna go ahead and use 5 kilograms as your mass to figure out what what the time would be. And this time itself will be a little bit different than the time over here. And I'm gonna explain using a new concept in just a minute on the left hand side of the equation. So I have to go ahead and show you how I derive the equation. Just hold on just a moment. So right now I would like you to go ahead and apply the concept you've done, or at least practice on problem solving. Just go ahead and play the number for me for now. Go ahead and leave that term for now. It will be your test to solve the problem. So you have everything you need. You know the gravity, which is 9.8. You know the height, which is 10 meters. You know, that's it, that's all you know. Then you can figure out what the time is. So now go ahead. To figure out the final velocity when it hits the ground, you can either use this equation if you know the height, or you can use this. Okay, this is your final velocity when it hits the ground. That's what you need. That's what you need to be solving for. This one is 0, remember? Do you know the time? You know the time. We get the time from this equation. So I'm gonna go ahead and write it down. That one is equal to g times time. I basically will be right on this term right here. So it will be 2 times the height divided by the gravity. And when you multiply the gravity by the time, eventually you will get the impact velocity. That's what we need to be looking at. So I'm just gonna go ahead and continue with the new lessons. This is the old semester, that's why I put it on this side. And this is the new information, that's why I'm putting on the left hand side. So right now, all you need to know for the new lessons are the equations written on the left hand side of the board. Let me go ahead and move the camera so that you can see all the equations. So at this point, you should be writing everything I had. So let's go ahead and figure out what this term is. So the new thing is t is equal to t period. So the time it takes for an object to complete one oscillation, which is moving back and forth. So period is the time it takes for an object to complete one cycle. That's what it kind of means also. So let's go ahead and look at what it is. Mass, you have the mass. Constant, you have the constant. All you will be looking for that constant depends on what they're giving you. So this new lesson is called simple harmonic. It's a type of motion where everything repeats itself. And these are the equations that you kind of need to kind of know by now, or at least write down first. You're not going to be able to use a lot of these equations because you only can use this one for certain thing. For right now, we're going to use this equation along with the graph itself. So let's go ahead and look at what's going on this left hand side of the equations. So as you can see, that the mass itself, right, is actually attached to the string, which is attached to the wall. So equilibrium position, this is where x is equal to 0. And then the object can be either compressed or can be expand. But as you can see, this one, is it compressed or is it expand? Tell me, you tell me. It's actually been pulled this way at a certain displacement, which is in meters. So right now we don't know what it is just yet, don't worry about it. All you need to know right now is the mass. So let's figure out what actually happened. I want you to go ahead and look at the velocity versus times graph. So velocity is 9 meters per second, and the times graph is 10 seconds. So an object is right here. This is where it stops. So I'm gonna go ahead and stop and start drawing. And then this object right here will be here. That will be traveling all the way at the maximum, at right here, at its equilibrium position. That's the highest velocity. And it goes down until it goes all the way here until where it should be compressed. So that velocity itself should be 0. This is what it is. So now you keep going this way all the way until it reaches the highest velocity. This is where we're coming back at this point. And then to complete the cycle, we need to go back to where it originally is. So basically, the time it takes for these oscillations to complete, it will take 7 seconds. Okay, and the velocity, the maximum velocity, is equal to 1.6 meters per second. So let's go ahead and look at what's going on. So I'm using the chalk for the experiment 1, and I'm gonna go ahead and explain experiment 2 in just a minute, where there will be a rough surface involved, which is obviously the friction will do the work also, but we're not gonna talk about the work, but we're just gonna go ahead and talk about the frictions and how the friction involved in the oscillations. So I want you to go ahead and write it down, the equation first. So this is the first thing you need to know about how the old lesson tie into the new lessons. So the first thing we do is for you to figure out what this symbol is. But I'm not going to explain what it is just yet right now. I just want you to go ahead and look at this one, since we kind of going to only use this 1% thing. We're not really going to be talking about this until we get back to the next lesson, which is the rotational motions. Basically, what we learned right here is translational only. There's no movement involved. It's only going that way or this way. There's no rotation involved. That's why we call translational. So let's start with what we have. Remember that we have, I'm using this one because I know what the T is from this one, which is the time it takes to complete one cycle only. So we start with the original, which is 0, all the way to the maximum height. Go back to the 0, go all the way to the maximum velocity, and go back to where it is. This is the motions. We take 10 seconds, so I want you to go ahead and write it down. 2 pi divided by 7, and give me the answers. Go ahead and find the number for me, please. Okay, one more question. I need to make an correction. So it's 0.7 instead of 7. So I'm gonna have to remove the this one. But remember, what you're actually learning from this video is how you would apply a certain concept, not the number. I'm just using number for you as an example. And the answer will be 0.9. It's radian per second. That's the unit for this one. And then we're gonna use this to derive how we would figure out what the velocity versus times equation is. So remember that this equation right here is not exactly the same as the velocity right there, because they're not the same lessons. They're not the same types of information. So this one will be expressed velocity versus times graphed. So I'm gonna go ahead and write it down. V max times psi, this and that. So from here, do you understand what we have? Velocity versus times equal to minus or negative velocity max psi omega t. That's the expressions, right? So now I'm gonna go ahead and look at the graph that you need to be interpreting. So what would happen to my the maximum velocity, which is 1.6? Oh, sorry, 1.6. So you're gonna go ahead and write down 1.6